Next, backtracking problem is called letter combination of a phone number. We are given a string containing digits from 2 to 9 inclusive. We have to return all possible letter combination that the number could represent. We can return the answer in any order. A mapping of digits to letter, just like a telephone box, is given below. We don't have any mapping for the number 1. So for example, number 2 will correspond to the set of candidates A, B, C. So if we have a number 2, just in the example 3, we can form three new strings, each containing only one letter. And for the candidates, we can use A, B, and C. More interesting example is the first one. We have 2 and 3. So for 2, we can either choose A, B, and C. For 3, we can choose D, E, F. And we will see all of the possible combination using these six candidates, or pairs of 3 candidates, basically. Now, just in the example and just in the problem that we already solved, letter case permutation, once we start, we will basically have 4 options at maximum. For example, number 9 has, let's say we have number 9, we will have W, X, Y, and Z, and we will be incrementing our index, and we will be generating a string that we will be passing inside our helper function. And once we hit the end of our set of candidates, which in our case is just a string of containing the digits, we will just put the string that we have already generated inside our list that we will return as the result. Now, for example, if the next next digit is 3, we will, for W, D, E, F, and so on. So the maximum width that we can have is 4, and the maximum depth that we can have here is the number of digits that we have, which is n. So the time complexity will be 4 to the n times the computation that we do on the leaf nodes. And in our case, it will be n, because we will be using string builder to generate a new version of the string using the digits, and we will convert that string builder to string, and we will insert it in our result. First, we will check if the digits input that we got is empty. If it's empty, we just return the empty list, because we cannot form any string from no digits. Next, we will declare our result, which we will be inserting our strings that we are generating, and we will also return it as the final result of our function. We will do the mapping. So each entry to the list will have list of lists, and each element of the list will be just the candidates that we can use for a specific digit. Next, we will call the helper function, and after we are done traversing through the recursion tree, we will return the result. Now to the more important part, the helper function. We are taking a string s as the set of the candidates, set of the digits that we can. Our default value for the index, the first candidate that we are observing, will be as always 0. We will also pass the mapping so that we can map the current digit, the current candidate, to the set of letters that we can transform that digit to. And we will pass string builder, which will represent our current value that we are generating, and the last parameter will be the list of strings, and there we will be inserting that value that we are generating, which brings us to our base case. If the index is at the same, it's equal to the length of the string, we don't have any candidates, so we will transform our string builder to a string and add it to the result list. We will return, so we don't go down the level inside the recursion tree, we go up. For the regular case, we will get the current character at the index that we passed as a parameter to helper function. We will get the mapping by first transforming that digit to a number, and then offsetting it by 2. So for example, the digit 2 will be 2 minus 2, which will be 0, which will correspond to the first list in our list of mapping, so ABC. Next, we will traverse through all the letters, and we will basically append the letter to the builder. We will call the helper function recursively. And once we are done with recursion, we have to backtrack and we basically just remove the character that we have added before we went to the down the level. So we are recursing back.